In our last video of this section, we have 3 examples. The first one, number 12, is probably the easiest. I guess 12 and 13 are. 14 will take a little more thought. Let's look at 12. 2 students are selected at random from a class of 10 juniors and 9 seniors. Find the probability that both students chosen are juniors, and then that both are seniors, and then one of each. And it's saying, is this a combination problem or a permutation problem? Well, we're not ordering them, we're just choosing 2 students. It's not choosing 2 students where one is the president and one is the vice president, so order matters. We're just choosing 2 students. So in all of these, the denominator is going to be 2 students are selected at random from a class of 19. So the denominator is going to be 19 choose 2. So for the first question, find the probability that both students are juniors. Well, all we have to do is say, how many ways can we choose 2 juniors? There are 10 juniors to choose from, and we need to choose 2 of them. That's the answer. Now, I haven't reduced it, of course, but let's say this one is A. So I'll say that's A, that's B, and that's C, the questions. Probably should have started way over here, but let's do the second one. It's going to be just as easy as that one. B, well, the denominator is how many ways we can choose 2 people from that group of 19, just like this. And the numerator is how many ways can we choose 2 seniors. There are 9 seniors to choose from, and we need to choose 2. That's the answer. Not simplified, but you get the idea. You know how to simplify that. So let's see. C. The denominator will be the same. I want one of each. So the denominator is how many ways I can choose 2 out of the group of 19. That's the total number of possibilities. How many ways could I choose one of each? Well, it's quite simple. How many ways could you choose 1 senior? Well, there are 9 ways to choose them. So there are 9 different seniors to choose from, so that's 9. Or 9 choose 1 if you want to think of it that way. And then how many ways could you choose a junior? Out of the 10, if you want to choose 1, it'd be 10 choose 1. I'm just going to write that like 9 times 10. And let's see, I guess I should simplify something. Maybe I'll simplify A. A, continuing down, will see 19 2. 19 choose 2 is 19 factorial over 19 minus 2 is 17 factorial 2 factorial. And if I cancel the 19 factorial and the 17 factorial, I would just get a 19 times 18 on top over 2. And then cancel the 18 and the 2 to give me a 9 on top. So we have 19 times 9. 19 times 10 would be 190. 180, I think that's 171 if I am not mistaken. You could double check that with your calculator. So the denominator is 171. 10 choose 2, I think I've done that on the board before. That's just 10 factorial over 8 factorial 2 factorial, which is 10 times 9 over 2, which is 90 over 2, which is 45. 10 choose 2, plug it into the formula, you'll get 45. So that's the simplified probability. Technically, it's not completely simplified because 9 goes in to both of these numbers. So I would have to, let's see, to completely simplify it, divide both numbers by 9. Let's see, 9, 180 would be 20. I guess that's 19. Once again, double check that. And I'll let you do B and C, plug them into the formula, do all the canceling, and write it as a simplified fraction. Okay, let's see. 13. 2 cards are selected from a deck of 52 cards. Find the probability that both are kings. Technically, we could use combination or permutation for this one. I think it's best to use just a combination. And essentially, when you make a fraction, a probability, if you use combination on top, you need to use combination on the bottom. If you use permutation on top, you need to use permutation on the bottom. Now, we might do an example like that next. Okay, so 2 cards are selected, are randomly chosen from a deck of 52 cards. That means I already know the denominator for this problem. The experiment is drawing 2 cards. How many ways can you choose 2 cards out of a group of 52? 52, choose 2. That's the total number of possibilities for pulling 2 cards out of a deck. Find the probability that both are kings. Well, how many ways can you choose 2 kings out of the deck? How many kings are there? 4. How many ways can you choose 2 of them? Out of the 4, choose 2. So let's see. Let's go ahead and work that out. I think C42 is 6. That's 4 factorial over 2 factorial, 2 factorial, which is 6. I'll let you do the arithmetic on that. Remember, 2 factorial is just 2, so the denominator is just a 4. The next one's not so pretty. C52, 2. 52 factorial over 52 minus 2 is 50 factorial times 2 factorial. That happens to be 52 times 51 over 2. The 50 factorial canceled with the above. So let's see. 52 cancels with the 2, leaving a 26 upstairs. So that's just 26 times 51. I'm going to leave it like that. I don't have a calculator. So final answer is 6 over 26 times 51. A very, very small number. All right, last problem for this section. A box contains 15 light bulbs, 4 of which are defective. So if 4 of them are defective, that means how many of them are good? 11. Means 11 are good. So let me draw a picture. It's going to have 15 total. I'm going to put 4 bad, 11 good. I changed over from defective and non-defective to be good and bad, bad and good. 4 bads, 11 goods. That's what we're starting with. If 4 light bulbs are randomly chosen from this box, so I already know what the denominator is going to be, find the probability that all 4 are defective. It says do it in 2 different ways, using combinations and permutations. I think I'm just going to use combinations. We'll see how it works out. Okay, so what's the denominator going to be? It's going to be the number of ways that you can choose 4 light bulbs out of this whole box. So it's going to be 15, choose 4. That's the denominator for the problems. How many ways, when you choose 4 of them, how many possible ways could you choose 4 defective ones, 4 bad ones? Well, there are only 4. So C, 4, 4, which is 1. There's only one way to do it. You have to take all 4 of them and leave none of them behind. You can plug that into the formula to verify that's true. So this one was fairly easy. What should I do with that? 15. I think I'm going to leave U to simplify that. Basically, maybe I'll get you started. 11 factorial, 4 factorial, which would be 15, 14, 13, 12. The 11 cancels out. 4 times 3 times 2 actually is a little easier than I thought. 4 times 3 is 12, so the 12 cancels with the 4 and the 3. The 2 cancels with the 14, leaving 7. So 15, 7, 13. You can use your calculator to compute that, but a very, very small probability. It's highly unlikely that if you're going to choose 4 out of this group randomly, that you're going to choose the exact 4 bad ones. Okay, so what is the probability that 3 are defective and 1 is good? Well, without simplifying, it's just going to be this. That's the denominator. And the numerator is going to be, how many ways can I choose 3 from that group of 4? 4, choose 3. And then I have to choose 1 from this group of 11. So C, 11, 1. Which we all know is just 11. Let's see here. How many ways can you choose? If you plug that into the formula, that's the same as the number of ways you could choose 1 out of a group of 4. Because when you choose 3, you're leaving 1 behind. We saw that in class. I just happen to know that's 4 times 11 on top. And did we do, yeah, we did the bottom as 15, 17, 13. So I'll let you plug that into your calculator, maybe write it down as a decimal, and it'll be a pretty small number, but it'll be bigger than this one, than the original problem. Okay, how about the probability of exactly 2 being defective? Another way of saying that is 2 bad and 2 are good. So I have to choose 2 from this group and 2 from this group. That's simply going to be, the denominator is the same, choosing 2 from the group of 4 times choosing 2 from the group of 11. And I think that was 6 times, and 11 choose 2 was 11 times 10 over 2, which is 55, over 15, 7, 13. I just noticed I made a mistake right here. It's 15, 7, 13. So that's 15 times 7 times 13. Last one looks straightforward as well. None is defective. That means they're all good. So it means you're choosing 4 from this box, and they're all from this group. How many ways can you choose 4 from this subgroup right here? 11 choose 4. So we're going to have 11 choose 4 on top, and 15 choose 4 on the bottom. Now, just, I don't want to confuse you, but you're technically choosing all 4 from this group and 0 from this group. So technically you could put this down as well. From the group of 11 goods, you're choosing 4 times what you're choosing 0 from the group of 4. This, if you plug it into the formula, remember, whenever you choose 0, it's a 1, so that's not going to change the answer at all. So maybe I'll just figure out what 11 choose 4 is. Did we already do that? We did not. That would be 11 factorial over 7 factorial, 4 factorial, which is 11, 10, 9, 8 over 4 times 3 times 2. The 7 factorial canceled out. That's why this stops at 8 right here. 4 times 2 is 8. So I canceled the 8 on top with the 4 and 2 in the bottom. The 3 and the 9 would leave me a 3 upstairs. 11 times 3 is 33, times 10 is 330. So we would get 330 times 1. I'm not going to bother with that. And then, I'm sorry, that's the denominator. That's the denominator. Nope. Had it right the first time. Sorry about that. 11 choose 4 is 330. So that is the numerator. And then the 15 choose 4 is what we did upstairs. It's 15, 7, 13. 15 times 7 times 13. And that, of course, would simplify. 15 goes into 330, for example. But you could plug that into your calculator and come up with that. That'll probably be the biggest percentage among the 4 of them. So, rather time-consuming, but not terrible. And that is the end of this section.